All right, so let's get into the steps, procedure, and logic. So for the steps, so we have to first decide what parts we need, right? So as you can see,
we decided to go with a motor.
Yeah, it's just stuff we found around the house that we thought would be applicable. Like we have a button on this side. So for the motor, we decided to go with an EV3 motor because it was the strongest motor that we actually have on hand. We realized that we could not find a single motor anywhere near us, and it was only through Amazon that we could find anything.
And so we just decided to go with whatever we had lying around, and we made it work, and we'll explain that in the next video. But moving on.
Yeah, and obviously the motor's main function in this whole project is to push down the tap and make sure that the water gets distributed. And we also made sure that the motor would push down in intervals, so each time it would go up and down in every 5-second interval, so we would be able to get the sensors to sense the water. We'll get into that a little later.
Yeah. Okay, so let's go into what actually constitutes our project. So there's a motor, 2 ultrasonic sensors, and the actual tank which houses the water,
as well as the lever that's pushing down the tap.
Yeah, as well as the lever. Okay. So now let's talk about how it all comes together. So the idea is that when you put your cup underneath it, it's able to continuously pour water into the cup until it reaches 2 centimeters till the rim of the cup. So how about we talk about the logic for the code?
So the main logic behind the code is we have 2 sensors. The front sensor will be able to measure the distance to the rim,
right?
And the back sensor will be able to measure the distance to the bottom of the cup.
So when there's no water in the cup, basically what the front sensor and the back sensor are sensing is the distance from.
Hey guys, to make this a bit more clear, the ultrasonic sensor farther from the tank detects the distance to the base of the cup and is denoted by the variable y in the drawing. On the other hand, the sensor closer to the tank determines the distance to the rim of the cup and is denoted by the variable x. By subtracting x from y, we get the initial height of the cup.
Rim all the way down to the bottom, and
it's
finding the cup height by subtracting these 2 distances.
Yeah. So we record this value separately, and then through the code, we continuously run it for many intervals. So it'll constantly press down, go back up, press down, like for 5-second intervals, and then check the height for 100 milliseconds.
Yeah. And so basically, as the water keeps on filling, the cup height will keep on changing. Right. And that way we'll know how far the water is to the rim.
Right. And so basically...
Hey guys, to explain this idea in more detail, if you compare this diagram to the previous one we showed, y minus x in the current diagram yields a smaller value than that of the previous diagram, and this is because the water height has risen. Thus, in order to better understand what we're talking about, think of the cup height and subtraction variables that we constantly mention throughout this video as the height of the water in the cup throughout the dispensing process.
How it would look is that if this is the original cup height, as you're adding water, the base is basically going up. So once it reaches 2 centimeters, that's when it stops the process.
And the lever will just go up permanently.
So make sure when you're actually using the sensors, it's also very important to log the values that you're getting, so that you don't get any errors. Like I know that in our original code, we weren't logging properly, so we're getting very confused. So
print statements and that kind of error checking is really important.
Right.
And also moving on to the way that the ultrasonic sensors work. So the reason why we used ultrasonic sensors is because it can sense distance from water as well. And there are 2 sides to the ultrasonic sensor. It's like 2 circles like this. And one of these sides is an echo, which will send out a signal. Or
it's the trigger,
other way around. Sorry.
So there's a trigger pin and there's an echo pin. The trigger sends out a signal, and that signal bounces back and hits the echo, and it's able to calculate the duration in which the bounce happens.
Yeah, and it calculates that and saves it as a millisecond value. And there's an equation, a common equation, that is used to convert milliseconds from the ultrasonic sensor into centimeters, which is a lot easier for us to use. And once we converted both sensors values into centimeters, that's when we found the distance, and we could stop it at 2 centimeters exactly.
2 centimeters, yeah.
So one thing I would like to add is that when you're working with the ultrasonic sensors, try not to get anything wet. So like, what is it? When we were using the ultrasonic sensors, we didn't calculate how far we should actually make the cardboard housing the ultrasonic sensors to the tap. So we ended up drenching the whole thing. But luckily,
and I also may have dropped the sensor into water once.
Yeah, but we have prevailed.
Yeah,
that's what matters.
And also, this might be pretty obvious, but also make sure that the sensors are parallel to each other.
Oh yeah, that's actually very important because it measures in like very like minute differences of like it can be even 0.01 of a centimeter off sometimes. So it's important that they're like right parallel, so that difference is like as like diminished as possible.
Also, centimeters are like the actual distance has to be very precise in this project because the whole thing is getting to the rim 2 centimeters away. So any loss of data or if the sensor is not like getting the correct height properly, you should always make sure that it's a logical estimate.
So originally we were gonna make the water fill up till the rim because first of all that would look impressive, but like Umesh said, you have to have the like really accurate positioning of the sensors, which is why we decided 2 centimeters was a good amount to choose because it would allow it to first of all go most of the height of the cup, and it would also give us a little bit of space to.
And also adding to that, the refrigerators don't fill up water all the way to the rim. So it'd be good to stop it a little bit before the top so that you can actually take the cup without spilling anything.
Alright, so that's the steps and procedure. We'll get into the problems in the next video.